Pascal's triangle consists of a 1, then I listed that for you over there. And the way it works, you add those two, you add those two, you add those two, add those two, and I'll show you how that works. So Pascal figured something very important. Pascal figured if you take a plus 1 to the 0, that's a 1. That's this. Then said if you take a plus b raised to the 1, that is a plus b. Correspond to this. So these are the coefficients. Pascal figured if you take a plus b squared, that is a squared plus a to the 1 plus a to the 0. So he figured every time you have two terms added that are raised to a power, added or subtracted, you start with the first being raised to that power, but he figured that each term must have a power of 2. This has a power of 1, so b must take the 1. Now the power of those is a 2. Since that's a 0, b must pick up what's left. So he knew also, if you look at a plus b to the third, he knew it's going to start with a cubed plus there's going to be an a squared. A is going to run in order from a being to the third power to 1 and 0. And since each of those must have a power of 3, this has a power of 3, this has a power of 2, that means b must be to the 1. Now the power is 3. If this is a to the 1, that must be b squared. Now it's a power of 3. And since that's a 0, it must be b to the third. We normally don't write a to the 0. And if you look at a plus b to the fourth, he figured it's a to the fourth plus a cubed. That means b must pick up the 1 because you need a sum of that power to be 4 every time. Then a to the 4, a to the third, a squared, that means b must be raised to the second power, a to the 1, that means b must be raised to the third, and a to the 0, that means b to the fourth. The problem he had was these numbers. These numbers were an issue. What goes there? So instead of foiling this 4 times or 5 times, he figured, well, look, the coefficients are right there. A plus b squared will take a 1 to 1. 1 to 1. A plus b cubed. Add those two. Add those two. 1, 3, 3, 1. 1, 3, 3, 1. A plus b to the fourth. A plus b to the fourth would be, add those, so that's a 4, that's a 6, and that's a 4. These are the coefficients for a plus b to the fourth. A 1, a 4, a 6, a 4, and a 1. The issue with Pascal's triangle, you need to list that many terms every time if you want to go. So if he wants a plus b to the 10th, he needs to list the first 4 or 5 terms. So that's really how he figured it out. I kind of cluttered that. Let me make it simpler. So that's the idea. This was to the 0 power, to the 1 power, to the second power. Oh, okay, it doesn't fit. That's why it's not working. Not a problem. So if I add those, that's a 2. If I add, I should have gave it more space. That's add those, that's a 2. Add those, that's a 3. Add those, that's a 3. If you add those, 4, 6, 4. I'll tell you what. I'm not liking that at all. Let me start fresh. So, 1, 1, 1. 0, 1, 2, 3, 4, 5. Do we have more than fifth power? They only go to the fifth, so that's okay. That's a 2, 3, and 3. 4, 6, 4. 5, 10, 10, and 5. So this is the 0 power. This is the first power. Second, third, fourth, and fifth. So when they say use Pascal's triangle to expand, well, we know that this is going to be x to the third plus x squared. That means 2 is going to pick up the 1. X to the 1, that means 2 is going to pick up squared. And no x, that means 2 must be raised to the third. That's pretty much it. Now the coefficients. The coefficients are always going to be using Pascal's triangle in this case. A 1, a 3, a 3, and a 1. And then you could simplify. 2 times 3 is 6x squared. 4 times 3 is 12x plus 2 to the third is 8. And if you multiply this by itself 3 times, that is what you get. Imagine if you want to multiply this by itself 5 times. The coefficients are right there. But the numbers, or the terms, 2 to the x is going to be raised to the fifth. The next term will have 2x to the fourth. The next term will have 2x to the third. The next term will have 2x squared. The next term will have 2x. And the last term will simply have x to the 0, if you will. Now that means here, this has a power of 5, this has a power of 4, that means negative 1/3 is raised to the 1, that's a power of 5. This is cubed, that means negative 1/3 is raised to the second power, negative 1/3 raised to the third power, plus 2x, I need more space, 2x raised to the 1, that means negative 1/3 is raised to the fourth, and the last term will have a negative 1/5, negative 1/3 raised to the fifth power. Now, the coefficients of those, 1, 5, 10, 10, 5, and 1. So, a 1, a 5, a 10, a 10, a 5, and a 1. So this will be 32x to the fifth minus 2 to the fourth. 2 to the fourth is 2, 4, 8, 16. 16 times 5 is 80. Plus 2 to the third is 8 times 10, that's 80. 80 over 3. Plus, I'm sorry, it's not plus, it's minus. Minus 2 squared is 4. 4 times 10 is 40. Plus 5 times 2 is 10 over 3 to the fourth is 81. And the last term will be 1 over 81 times 3, 243. The issue with Pascal, again, if I want the 50th power, I need to list this 50 times. And that's where the binomial theorem came in, and it turns out to be a bit more useful to find specific terms than Pascal. We need to talk about factorial. if n is a natural number, in case you've forgotten, natural numbers are the counting numbers. If I say start counting, you'd say 1, 2, 3, 4, all the way up. So it's kind of like positive integers. N factorial is n, whatever this is, times 1 less, 1 less, 1 less. You'll keep on multiplying until you get a 1. And 0 factorial is defined to be 1. So evaluate for factorial. That's 4 times 3 times 2 times 1. That is 6 times 4, that's 24. Done deal. Evaluate 5 factorial. Well, 5 times 4 times 3 times 2 times 1. Wouldn't you say this is 24? So 5 times 24 is 120. And what do you suppose 6 factorial is? Well, isn't 6 factorial 6 times 5 times 4 times 3 times 2 times 1? Didn't we just do this? So wouldn't you say that's 6 times 5 factorial, because 5 times 4 times 3 times 2 times 1 is? And 6 times 1, 0, 12, 720. 7 factorial, I'm going to write it out for your notes because we just saw this. That's 7 times 6 times 5 times 4 times 3 times 2 times 1. Wouldn't it be sufficient to me to say 7 times 6 factorial? And that's going to be 7 times this, since I already did that. So that is 0, 14, 49, 50, 5,050, not 45. 5,040. Now, something that comes up in statistics we need to use. Let n and k be positive integers where n is bigger than k. The method of selecting n objects from a set of n objects, I'm not talking about identical or all of that. When the order does not matter, we don't need to worry about that in this class because we're going to only do this case. It's called the combinations n choose k, and n choose k is defined by n factorial over k factorial, and the difference between those factorial. It's a key on your calculator. You gotta find, and it's right, oops, it's right there. Clear? It's C. So right there, NCR. There's NPR, we're not gonna worry about that. So when I say what's this, you're gonna write, I want you to write it out first. That's 6 factorial divided by k factorial, 4 factorial, and the difference of those. So the denominators must always add up to the 6. And to figure this out, you could just plug in the calculator. You could simplify it by hand. I can care less. You could say that's 6 times 5 times. Can't I stop at 4 factorial? Do you notice we could stop anywhere and put a factorial? That does work. And that saves me time. I'll show you why. Instead of me writing, by me writing 4 factorial, instead of writing 4 times 3 times 2 times 1, I know that's going to be the same. So instead of writing this out, I could have stopped at 4 factorial and cancel it with that factorial. 2 divided 6 3 times, that's 15. I could get on my calculator and say 6 choose 4. And again, you're allowed a calculator, but you need to understand the analogy that I'm talking about. 6 choose, what do you say, 4? 15, there you go. How about this one? This is 6 factorial over 2 factorial. And again, you subtract those, or you say those must add up to 6, so I'm missing a 4 factorial. 6 times 5, since I see a 4 factorial, once I get to 4, I stop. This is 2 times 1, 4 factorial, those cancel out. This is 15 again. A coincidence? Well, we're not really looking at this from a statistics point of view, so I'm not going to elaborate on that as much. How about 16 choose 2 factorial? That is 16 factorial over 2 factorial. And what do you add to 2 to get 16? Do you see here, instead of me writing 16 times 15 times 14 times all the way down, it's probably more beneficial to say 16 times 15 and stop at 14 and put a factorial, because those cancel out. 2 divides 16 8 times. 8 times 15 is 120. Of course, I could use my calculator. I need you to learn this by hand because we're going to need it. There you go. 99, choose 96 factorial. Well, this is 99 factorial divided by 96 factorial. And what do you add to 96 to get 99? 3 factorial. So here it would be very beneficial for me, instead of listing that 99 times, is to go and use this trick I've been telling you. 98. Keep on reducing that until you get to this. Even if I had to multiply, it's much easier to multiply this than to multiply the top. I could do this by hand. I could use my calculator. 99 times 98 times 97 and divide that by 6. That is 156,849. 156,849. Now, what if I decided to take 99 NCR 96? There it is. So here we are. I have a bit more. I want those clarified. The special cases. 6 choose 6. That is 6 choose 0. That's 6 factorial over 0 factorial. Remember, what do you add to 6 to get 6? Wouldn't these two cancel out? And what's 0 factorial? That's the only non-zero number. 0 factorial is the only 0 that's not a 0. And how about f? Well, this is 6 factorial divided by 6 factorial. What do you add to 6 to get 6? You add 0. So what does that mean? If I have a number of objects and I'm choosing none, there's only one way of doing that, by not choosing at all. And if I have 6 objects and I'm choosing all 6 of them, there's only one way of doing that. I gotta choose all of them. What if I have 6 objects and I'm only picking up 1? How many ways can I choose 1? Well, that is 6 factorial over 1 factorial. What do you add to 1 to get 6? 5 factorial. That is 6 times 5 factorial over 5 factorial. 1 factorial is 1. So that is, there are 6 ways of doing that. Either you choose the first, or you choose the second, or you choose the third, or the fourth, or the fifth, or the sixth. In general, if I have n and n minus 1 factorial, that's n factorial over whatever this is factorial. Now, what do you add to n minus 1 to get n? 1 factorial, or you could subtract those two. Right? And isn't the top bigger than the bottom? So if I leave the bottom alone, isn't the top n? What's the next term? N minus 1, and you can slap a factorial anytime you want. And there it is.